so these are some things that you can, but not necessarily should, do with threads in Ruby on Rails. So Ruby gives us a thread class that we can use to implement concurrency. What this means is we can divide and conquer. We can break up work among multiple threads and do things a little bit faster. But wait, some problems. With concurrency, we get things like race conditions, deadlock, synchronization issues, and we got to worry about overhead. We call something thread safe if it's pretty resilient to these issues. Okay, counter our first boss, the producer-consumer problem. This is where we have a producer thread, a consumer thread, and a shared queue. And the producer will put things into the queue, the consumer will take things out. We need to worry about the producer not putting in anything into the full queue and the consumer not taking anything out of the empty queue. But look at this. Ruby gives us a queue class, and look, here we go. The queue class implements multi-producer, multi-consumer queues, and there's a thread example of the producer-consumer problem there. But let's be real, we're all probably using Redis anyway. You can use a Redis list with like rpush and lpop to do the same thing. It's pretty thread safe in my experience. So I've used threads and a Redis queue here in my Economy Simulator 9000. I got some producers producing some widgets and some consumers that will consume them. And you can see how the supply and demand ebbs and flows depending on the number of producers and consumers that you have. By the way, I'm also using Ashen Cable here to send, to transmit data from individual threads to the front end. That's how I'm able to visualize the threads there. Now we have our second boss, deadlock. This is where everyone's waiting for a resource to become available, but it never does. You might be familiar with the dining philosophers problem. You got 5 philosophers, 5 chopsticks. Every philosopher shares a chopstick with their neighbor, but you have to have 2 chopsticks in order to eat. So what you can do is use a mutex. So here the philosophers are the threads. The chopsticks are the resource that we can actually use a mutex on. And this basically serves as like a bouncer to the resource, be like, hey thread, resource is busy, you're gonna have to wait. So I've also implemented that in my little demo app. You can see the philosophers will wait for their chopsticks to be available, and then they can take a bite to eat. They'll put them down and think, but philosophers will have to wait for their neighbor's chopsticks to become available. Now we have our third boss, too much overhead. More threads does not always equal more fast. So the cost of spinning up too many threads can actually make things slower. And just be aware that not all problems warrant concurrency, so just be aware of that. I have another little report generator simulation here. I'm generating 100,000 rows and 5 columns, just a bunch of random data. My first one is generating with 1 thread at the bottom, 2 threads, 5 threads, and 10 threads. You'll see the 10 thread one will finish first. It's able to do a lot more work in a short amount of time. But if you were to say bump this up to like 100 threads or 1,000 threads, the overhead of that might actually slow things down. So to recap, threads are awesome, but don't shoot yourself in the foot. Ruby provides many out-of-the-box solutions to concurrency and thread safety. You can transmit data out of a thread while it's running using Ashen Cable, but again, don't shoot yourself in the foot. Be aware of overhead and don't pile on more threads than you need. And just always question if a problem even warrants concurrency in the first place. I'm Michael King, senior dev at Triple Seat. There's some of my info and a QR to the repo if you want to check it out.